Good evening, everyone. Hope you and your family are doing well. GDSC VIT Bhopal welcomes you to our first ever Android 12 meetup. This is Ishika Kulkarni, and I am the lead at Google Developer Student Club VIT Bhopal University. Now, talking about Android is one of the very basic frameworks for development. And at GDSC VIT Bhopal, we give credence to developing your Android skills. We have been working on various projects and blogs and tutorials which can be found on our YouTube channel and as well as our blogs and our GitHub page and Medium as well. So today the agenda will be discussing Android development and the new features of Android 12 and Jetpack Compose. The highlights of this session would be coding, the UI UX, privacy, security, and development, and all about Android 12. We will also be focusing on Jetpack Compose, which is the new toolkit for Android UI and UX development. Now, for today's session, I would like to invite Dhruv Mehta and Vishesh Tripathi. Dhruv is our Android lead and Vishesh is our Android co-lead, and they will be discussing about all these things in detail. Thank you, everyone, for joining, and we'll begin with the session.
So, hi everyone. I know all of you must be excited to get to know more about Android 12. So, throughout this event, we would be discussing a lot of things. The first thing we are going to discuss about Android 12, how Android 12 has changed the future of Android. Material U, I know a lot of you people must be knowing about Material UI or Material Design, but Material U is a brand new thing which was presented in Google I/O, and then we would be moving to Jetpack Compose. So, let's start with the part. So the first thing I would like to tell you that we would be covering throughout the Android event is we would be covering it in three major parts. We would start with system UI, then security, and then app startup. So coming to the part of UI, Android 12 is a major turning point of Android, as I told you in the beginning, with more dynamic, modern, and published UI that brings key changes to make Android feel faster with the speed and feel faster. So while the operating system will do most of the work, and we still need the apps to like yours to implement the new features and make the ecosystem better. And Android 12 is also the first step towards the Material U. If you don't know about Material U, just check the description or the chat box, the links would be there. A new design that will enable users to customize the device and make the apps feel more personal. And for more information, you can check the What's New Material U in the I/O session on YouTube. If you don't know about I/O, Google I/O sessions are conducted every year for introducing new features and technology in the field of Google developers. Now, we would be starting up with the polished part, the brand new stuff that has been added by Google into the Android terms. In the first version, we are bringing the device theme colors to your app by applying the theme.device default day night to automatically get all the device theme colors like background, accent colors, primary colors, and so on. If you see the colors, or you can even get a full range of color palettes from the system resources. On Pixel devices, we will go one step further, and those colors will be created on the user's wallpaper using color extraction. Now, the material design which you are looking at has been used the contrast colors that has been defined in the following PPT. Now, we could not make an Android redesign without improving a core feature in Android. We revamped widgets for Android 12 so that they can help you drive application engagement throughout the widget adoption. While we made sure that we provide the tools and resources to make a widget even easier to build and maintain. As you can see in the given slide, widgets in Android 12 will increase adoption, drive engagement, and will be easier to build, as you can see on the right hand side. Now, we would be adding more things into the widget paths. We would add more native support for interactive elements like checkbox, switches, and radio buttons. These things are totally different when you compare Android 12 to Android 11 or Android 10. Better supporting for tapping controls so users can engage with your app just from the home screen. On top of that, we are improving discoverability with a rapid widget picker, where you can provide a more accurate description of your widget with a preview layout and even widget description. Uh, we won't stop here. There are a lot of things to come to Android 12. We did not stop only on the home screen either. Your widget will be appearing in more places in Android 12, starting with Android's on-device search, assistant on mobile, and auto. If you don't know about Android Auto, be sure to check the chat box. There would be links provided to Android Auto. Android Auto is basically applications that are made solely for automobile. Like big companies like BMW and Hummer has been using Android Auto from a very long time. Now we would be talking about Material U, the thing I have been really excited to tell you all about. Material U would be directly brought to you into the home screen by enabling color capabilities so Android users and device makers can easily personalize device colors and the theme that extend to apps, but of course, widgets. And on Pixel, even the colors will even adapt to the wallpaper colors. Beside colors, Android 12 introduces system level resources which will allow you to launch the launcher to control the padding and corner radii automatically apply to the provide a consistent design across all the widgets. Now, there's a number of ways to customize the look and feel. In Android 12, we are making widgets look and feel harmonious alongside other widgets and app icons by introducing system level resources, which will allow the launcher to provide you the control padding and corner radii, as you can see in the given code. Referring to the checklist example on the right side, which you can see on your screen, this snippet allows you to add a system level resource for corner radii. This way, widgets automatically adopt themselves to look great on every launcher and home screen. Now, we have also added some dynamic colors. Adding dynamic colors was really simple as adding the system theme to your widget and using the color attributes defined in the system. You must be hearing the word theme from me a lot of times since I've been talking about Android 12. But in Jetpack Compose, theme has been a very major part when it comes to improving the UI part. Now, as you can see in the code snippet, making a widget reconfigurable starts with adding the reconfigurable flag. As you can see in the example, the widget on the right side has been added with the help of the code snippet in the left. Now, you can even check out the developer documentation and sample to learn more. The images that you can see in the following slide are part of the direct Google I/O events that have been conducted in the month of April and May. In that, Material U was directly introduced and connected with Android 12. This tells us Jetpack Compose, Material U, and Android 12 all are connected to each other. And now, Android 12 brings more consistency in the ecosystem. And an important part is the notification. We all crave for notifications. So that's why we are deprecating the fully custom notifications. For apps targeting Android 12, the system applies a standard template in order to provide a more consistent user experience for notification, such as for the icon, app name, and expansion and collapse of the standard notifications. You are strongly encouraged to update your app's target SDK. All the Android developers who are listening to this, you are strongly encouraged to update your app's target SDK and verify that the notification layout looks right, including expanded collapse state and heads up notification. Now, you must have noticed the glow effect when you try to scroll any scrollable an item on the end or the start. The glow hasn't changed from years. Means if you are using Android 6 or Android 7, even you would notice that it hasn't been changed from years. I guess it's around 5 to 6 years the particular feature hasn't been changed. For apps targeting Android 12, we will apply the new over scroll with a stretch all effect to the overshoot behavior. This has been targeted to improve upon the existing UX components that have been provided to give a more natural scroll stop indicator. This behavior might affect certain custom list or behavior when it comes to updating your app's target SDK level and verifying that scrolling containers contains all the new overscrolling behavior. This concludes the system UI part, but that's not the end. As I told, Android 12 has been made of three new things, and the second is security. So my fellow mate Dhruv is going to guide you to the security part from here.
All right. So thank you, Vishesh, for explaining the US system UI part of Android 12. Now I'll be explaining the privacy and security part and other new things which are coming into Android 12. So let's begin. Is my screen visible? Can you
Yeah,
see
it's
it?
visible.
All right. So a major focus area for Android is privacy and security. Google's backset security for Android in Android 12, and therefore they innovated this area. Now, next thing is there are three basic principles which Google is covering in Android 12. The first is transparency, like around what data is accessed by apps and when. Second is control. So while providing simple controls for users so they can make informed choices about enhancing or limiting an app's access to their data. And the third one is minimizing the data, like the scope of permissions so users are not surprised by the data that leaves their devices. So let's start looking into the transparency principle. So as you can see in the animation as well, so Google is adding transparency to microphone and camera accesses, as you can see in the slide. So going forward, users will know in real time every time an app accesses their mic or camera. If the access is unwarranted, users can quickly navigate to the app permission page to revoke permissions. You should review the use of microphone and camera and proactively remove unexpected accesses. For example, like when you are making an application for some use cases, make sure your app is not accessing these sensors before the users has clicked on a feature that needs access. So this thing should be kept in mind when you are developing your new apps with the SDK 12 target. Now, Android 12 wants to bring more control to users. So this will explain the control part of our privacy principles. So Google is introducing mic and camera toggles that enables the ability to disable access to microphone or camera for all apps. These toggles are designed such that apps do not need to do anything differently. Your app will continue to think that it's accessing the camera or microphone, but instead will receive blank feeds when the microphone or camera is disabled. The system will take care of promoting the user to remind them of the toggle state. These controls will affect apps regardless of the target SDK level. So this is a new feature coming, and when you will update, make new apps, so this feature does not require a target SDK level. This will be built in the Android 12 operating system itself. So continuing on with the control principle, like now the control is getting shifted to the location part as well. So users will be able to choose the level of location precision granted to your app from the location permission dialog. Like when you are giving the access to the app, like, so you will give the app location that do you want to give the location as precise or approximate. For most location use cases, coarse location access should be sufficient, which is the approximate location. However, if your use case needs fine location access, you will need to account for the fact that users may grant your app only coarse location. If your app follows permission best practices, you won't have much trouble to adapt to this change. So if like when you are making your app, you need to basically follow these steps to help you evaluate the impact on your app. Like validate your app's use cases. Does it like first check, does your app really need precise location permission, or it can work with the approximate one? And no effect if using approximate location permissions. If your use case needs precise location, you must declare and request both coarse and fine location permissions. We will look into this in the next slide. So as you can see, if you need precise location, must request coarse and fine together. You need to add the location of permission request on launch, get that method, and in that permission request the access fine location and access coarse location, both of them together. So related to the location permissions and following the data minimization principle, apps that target Android 12 will have the option to decouple Bluetooth scanning from the fine location permission for use cases like pairing devices. So you can explicitly say that you require Bluetooth scan, but won't be using it to infer location. Even better, use the companion device manager API, which provides a more streamlined UX among other advantages. So basically, you will be taking the Bluetooth scanning also, but you won't be using it for location permission. So now we come on to the data minimization. So there's a good chance that you may have some apps on your device that you haven't used for months. It happens to all of us. We have apps which we don't uninstall and they are kept in from years. So Android 12 expands the permission auto reset feature from Android 12 or Android 11 and unused apps and put the unused apps in a hibernated state. This means that the system will revoke any previously granted permissions which they have given to the apps. The system will also free up storage by clearing up cache of the apps which are no longer used. Any jobs and push messages will stop and your app will behave the same as if a user force stopped it. So this is the best thing, like data will be minimized and permission auto will be reset in the apps which you no longer use. So to conclude this overview, let's talk about startup performances, a major area this year. Basically, we'll be talking about what happens when an app is started up, like the splash screen, and what are the other things. Other things like suppose there is improving your startup time. So for that, improving your startup time, Google is introducing macro benchmark library to help you profile it, like how much time is it taking to open your app, and how can you minimize it or how can you make it more depending upon your use case. And Google is also introducing a new splash screen to all apps. Well, this saves a lot of Android developers because creating a splash screen is a headache in itself. And also ensure that your app links are launched correctly. Like when you click on a link, then your app should open that particular activity and fragment, and improve the launch of your app from a user's notification. Now let's talk into the splash screen part, like which is a major thing which Google is introducing in the startup time. By default, the system will use your app screen background, your app icon, and display a smooth animation while your app processes initializes you during cold startup. As soon as the app's first frame is ready to be drawn, the splash screen is dismissed. So it takes the user right into your app's experience. This new system will allow you to customize those parameters and even provide animated app icons such as duration and splash screen dismissal animation. This change is especially important if your app was already providing a similar screen, since it could cause splash screen duplication. So this is a major thing which is coming in splash screen. And as you can see, the two XML codes in this, basically the icon and the foreground color can be specified in your app theme using the attribute shown in the slide, as you can see in the XML layout. If you would like to further customize the splash screen, first retrieve a reference to the splash screen by the new activity.getSplashScreen method, as you can see in the code itself. So for example, the disappearing animation of the splash screen can be customized with the set on exit animation listener. So basically, as you can see, Google has in itself added a method for the splash screen in itself and given us many animations for it in the new Android 12. Like now I don't need to create my own custom animation, and when new splash screen methods, it's all built in. To learn more about Splash Screen API, check out the documentation and the sample. You can find the links below in the description itself. We know how it's important to have backwards compatibility. So please look out for the Splash Screen Jetpack library, about which we'll be talking within a few minutes about Jetpack Compose. So another thing is app links. So app links are not new. They were introduced to provide verified links of your app to entirely bypass the target app dialog. Unfortunately, though, we have found that developers often make mistakes in configuring their app links, sometimes causing more disambiguation dialogues to show up than other necessary. So in Android 12, first, Google is improving app links to reduce user friction resulting from improper setup and providing tools to detect problems. Google has made app links verification granular on a link by link basis. So if one fails, does not mean that your all links will be failed. Google has also added ADB commands to help you test. Basically, you can test all those app links in your emulator when you are coding on Android Studio. Secondly, Android 12 will take users directly to a browser for web links if no default app is found. So you don't need to give it permission again and again that open this app through this app or use Google Chrome or use Micromax, Micro Mozilla or anything. Thirdly, there are new APIs in Android 12 that let you check for domain verification states, and if needed, take the user to settings for them to improve domains of your app. Okay, now another thing is avoiding the notification trampoline. I don't know if many of you must have heard trampolines, but there are notification trampolines that creates bad user experiences. So these trampolines are these are the delay which trampolines are nothing but a delay which occurs when you open an app through a notification. So instead of directing the user to the target activity or screen, the app goes into a broadcast receiver or service to decide the next destination. This leads to a poor user experience like high latency, as you can see in these animations as in the slide as well. The first one is a trampoline which slowly opens the app, and the second one is fast. So all apps targeting Android 12 won't be able to launch an activity inside a broadcast receiver or service. that was started from a notification. It will directly open in the fragment or the activity. So before we conclude this section, another use case that is related to performance are the foreground services. It's very common for smartphone users to multitask on their phones. So foreground services were designed for multitasking and completing a user action. Like users could be listening to a podcast while ordering food, or checking their email while helping a friend with turn by turn navigation. If your app has multitasking use cases, it is probably using foreground services to implement long running and user initiated tasks at a high priority. Foreground services were designed for exactly these use cases that involve multitasking and completing a user action. Next, as you can see, 46% foreground services started from background. However, Google has found that almost half of the apps starting the foreground services as started from background. As you can see in the data as well, users are surprised with the unexpected and non-actionable foreground service notifications and find them very distracting. Additionally, foreground services take up valuable system resources, and the operating system can't prioritize resourcing effectively. So in Android 12, Google is disallowing foreground services launching their own background activities, and this change will apply to all the apps that target Android 12 default. Okay, so that was a really quick overview of some of the main changes on Android announced during this year. Now we will continue with the Jetpack Compose and explain that to you. So now we'll be taking a move and we'll be explaining the Jetpack Compose and the scenario involved with Jetpack, and how we are implementing it in Android 12, and how even you guys can get started, because Jetpack Compose is the new best thing coming into Android. So as many of you might know or may not know, so Jetpack Compose is Android's modern native UI toolkit created to help you build better apps and make them faster even. And I would like to tell you guys that Jetpack Compose recently hit 1.0. This means that Jetpack is stable and production ready. From the past 1 year, it has been in beta stage, and like there were many bugs, but finally Google announced that now it has hit 1.0, and all of us can start using it in our apps. And I would also recommend you to use it in your apps. For more information, you can check this link out. Google/compose is stable, and also find that in the description or in the chat box in the live chat. So the next question should come is like, why did Google and Android, like why did they back a new toolkit? Like why did they create Jetpack Compose? So the existing UI toolkit, which comprises basically of views, like most of you must be using Android Studio and creating apps, you must be using the views like linear layout and everything, like all those views, list view and other things. So that has been available for over 10 years, like when the Android started, like from 2010. So in that time, technology has changed. Smartphones are more powerful. Users have higher expectation of apps, and UIs are much more dynamic and expressive. So they must have thought that why not we take advantage of this new technology, that smartphones are more capable now. And as the expectations of users have also excelled, then let's take the advantage and make something new in the toolkit experience, in the UI toolkit department as well. And as you know that still many of you who want to go to the default views, you can still create beautiful apps with views, but the thing is that they are slower and it takes more work in it. Like you need to design every view and every UI for every activity, every fragment, and nothing is given to you. So Compose is built on modern assumptions of modern architectures and powerful Kotlin APIs. And as you know, as you can see that we'll be using Kotlin, that's default. Okay. Another thing is that it gets unbundled releases as well with bi-weekly updates, just like Jetpack libraries. That means you can update at your own pace, and Google can ship updates and new features more frequently, which work on older platforms back to API level 21. So how does it make it even faster and easier? Like what does Jetpack Compose has that make it more faster and easier to use? So as you can see, we have mentioned that Compose is declarative UI toolkit. So let's break these two things into two parts. First is declarative and then is the UI toolkit. So first I'll be explaining about declarative part. So then the next we'll be covering the UI toolkit. So today's apps aren't static data. They update enormously. Like the database update is the live feed changes, the API level changes, the API feed changes. So they are alive. So you need to get along with the changes that are coming in the data of your application. So as you can see in this slide, traditionally with Android views, you would declare your UI in XML. As you can see in the blue box, there are certain UI XML elements. As you can see, the text view, button, and the linear layout. Like the linear layout is the layout, and then it must be having a button and a text view. Those who are familiar with Android app development, they must be recognizing all these things. So, but then you need to update your UI if any data changed. You need to mutate it. You do this by looking up views and setting properties on them. As you can see in the green box, you are looking up the UI by using the find view by ID method or using the binding libraries of Kotlin itself. And also you are setting up properties like using the tv.setText is basically textview.setText and setting the visibility of a button or adding a view like the linear layout view in the view parameters. Those who are familiar with Android app development, they can relate to this. So whenever your application state changed, for example, like I just told, if your database or a network call loads after a user interaction, you would have to update your UI with this new info to keep everything in sync. This can get complex as each view holds some state that you ensure you update. This overhead of synchronizing state between your model and your UI is a huge source of bugs. Like continuing with the database example, suppose the database has enormous amounts of text views, like it is taking a lot of text views. And if you haven't enabled a scroll view in it by default, so you won't be able to see the text that are coming after the screen is filled. So your UI remains static, but the data is alive and it is dynamic. So this is the problem which occurs basically in views and in the traditional system of views which we are using till last year or till now as well. So another thing is that declarative UIs like Compose take a different approach. They transform state into UI. The UI is immutable. There is no way to update it after it's been produced. So like if you have created a UI in declarative UI, you cannot change it. The UI remains the same. Now, suppose if your app state changes, suppose it went from state 1, it went to state 2. So Compose re-executes to transform this new state into a new representation. So the original UI which you created, the UI1, it did not change. The Compose in itself created a UI2 for having state 2 in it. So that is the power of Jetpack Compose. And this avoids the synchronization issues entirely. You regenerate the entire UI. Compose is actually smart enough to skip any work for elements that haven't changed to make it more efficient. But conceptually, it regenerates the entire UI for a given state. Your code describes what the UI should look like for a given state, not how to produce it. So basically, as I just told, if your state changes, you create a completely new UI. Jetpack Compose does it for yourself. Next, we'll take a practical example and I'll be going through the code and explaining you what is a declarative UI and how dynamic it is, and we'll see the things in Jetpack Compose. So as you can see, so like next question, like now we have discussed so much. So the next question in your mind should come, like how do you transform state into UI? Like just as I discussed that if your state changes, how does the UI changes? Basically that should be your question. So here is a simple component that displays a list of strings. As you can see in the message list, we have basically this is a message list and text is popping up inside that message list. So those who are familiar with Compose a little bit, so you can notice that in Compose, a UI component is simply a function with a composable annotation. As you can see in this, we have a function called message list. Now this makes it quick and easy to create UI components, encouraging you to break your UI down into a library of reusable elements. The function doesn't return anything. but instead it emits UI. So the function, as you can see, the message list, it emits UI. So, and in that function, we are having column and text composables from the Compose library, which arrange things vertically and display simple text label, basically simple text boxes, as you can see in the list form. So note that we can use the full Kotlin syntax and controls flow to produce our UI. So basically what they are saying is that Jetpack Compose is using Kotlin in itself, the original Kotlin language which you are using. So Jetpack is nothing different. For even creating the UI, you are using the same Kotlin language. And now using the for each method, you are iterating over the messages. So basically this is nothing but this normal Kotlin syntax, which if you have learned Kotlin, it is easy to understand. So, but if you want to conditionally show an element, like showing a label when there are no messages, like suppose if your list is empty, suppose you are fetching something from an API and your list, the API is not giving any list and it is empty. So it's not good to show an empty list in your app. There should be some text, some default text in place of your message list. Like in this, we can show no messages. The text box should show no messages if your message list is empty. Like you are using the message dot size is equals to 0 to check if the message list is empty or not. So another thing is that composables and can should accept parameters, like the function of message list should have a parameter. In this case, we are having the list string parameter. That's what we mean. That's what we mean by transforming data into UI. So the data in form of string which is coming to us is getting transformed into the message list. Composables take data as a function parameter and emits UI. In this way, the UI can't get out of sync. For example, forgetting to remove the no messages empty text. If your state changes, if the list of messages changes, then a new UI is regenerated by executing this function again. This is what we call recomposing. So recompose is nothing but you will again and again use this function message list, and this function will run again and again to create a new UI when your data changes or the state of the app changes. So as you can see, each composable is immutable. You can't hold a reference to it and query it later or update its contents. You need to pass any and all information to a composable as parameters when you emit it. So in this example, the message list string should be the parameter, and that is needed to be passed. But that doesn't mean that a component can't be dynamic. Like dynamic components can be your radio buttons, your checkboxes, your buttons. So let's dig into this by adding a checkbox to select all messages. So in this, we are taking the example of checkbox. As you can see, initially our checkbox is unchecked because we have put the check parameter as false. Unlike in the view world, when you are using XML layout and coding it in a main activity in Kotlin or Java, clicking this checkbox would not visually toggle it. Like when you are clicking on it, it won't be toggling it like tick mark and not tick. We have passed in a constant as it states after all. If we want to change it, the code must reflect that. So basically, if you want to change your checkbox to be ticked or unticked, basically you need to pass that through the code itself. Like there should be something which says that the check should be true now when it is on clicked, or it should be false when it is again clicked if it is ticked. So that should be done through the code, not through the XML layout. So let's introduce a local variable to control whether it should be checked. So as you can see, we are using a variable select all, which is a boolean in itself, and it can be true or false depending on your app use case. So checkbox offers an on-check change event when it is clicked. We can update our local state in this callback. Doing so will cause the checkbox to be re-emitted as it reads this state. It is important to understand that if we don't change any state in this callback, the checkbox won't update visually. So as I just told, that it will remain checked or it will be remain unchecked depending on what you have passed in the variable select all. Either it can be true or false. If it's true, it will remain checked. If it's false, it will be remain unchecked. At first, this might feel a little bit unintuitive that you need to write code to make a checkbox toggle when tapped, but this is the key concept in declarative UI. Elements are completely controlled by the parameters you pass through them. This is what produces a single source of truth. meaning that there is no other state to keep in sync. It's entirely up to you to decide how to react to the user. Pressing the checkbox, you might want to run some validation and only update the display if it's valid. Your code is completely in control, and rather than having to come back and undo the change if the validation fails. So there might be many a times that if you are using checkboxes, like I am taking the example of checkboxes in here, that you click on it and it remained checked. So now, if now in the default views, if you would have removed the if you have again clicked the checkbox, then it would have removed the check button. But the function which has passed through the clicking the checkbox must have gone through the app, and the changes must have occurred. But in this compose and in the declarative UI, that won't happen. Now, earlier we mentioned that compose will re-execute this composable function when the input changes. Basically, this was nothing but recomposing. However, there are variables we may want to keep across re-executions, or what we call recompositions. So this is basically recomposing the recompositions. Composable functions can remember a value from an earlier execution by using the remember function. As you can see, we have used the remember function in the variable select all, and this allows you to reuse a value in order to avoid reallocating it or to hold on to a state. In this example, as you can see in the code, we implemented the event handling inline, but for a more realistic example, we can instead pass in the state and update lambda as parameters. So basically what we want is that we can even pass these like variables inside the function in itself, and moving the logic up to wherever the source of truth is. So like rather than putting the variable inside the checkbox, we'll be passing it through the as a parameter in the function in itself, and then getting the parameters from wherever it is needed in the entire code. So now we are coming into the end part of declarative UI. Now, the key idea with declarative UI is that you completely describe what your UI should look like for a given state, and the framework takes care of updating the UI when the state changes. So that was it for the declarative UI part. Now my friend, the co-lead of Android co-lead Vishesh will continue with the UI toolkit part. Vishesh,
Yeah,
you can now continue from here.
I hope my screen
I'll
is visible.
just wait a minute. I'll stop sharing.
Yeah.
Yes, your screen is visible. You can go
Okay.
ahead.
So thank you, Dhruv. So we looked at how declarative paradigm works with easier to write UI. But built on top of this principle, Compose also offers a rich toolkit of UI components specifically designed for Android 12 and upcoming UIs. So Jetpack Compose provides the material design components and theming style, but the future is, as you know, Android U, and it offers the components and building blocks that you need to assemble your application, such as buttons, cards, tabs, and app bars. All components follow material styling out of the box, as you can see in the given code snippet and in the material design. So it also implements material theming, allowing you to implement systematically customize all components to your brand by supplying your own colors, shapes, and typographical styles. You can check in the description and chat box and look at how theming actually works in Jetpack Compose using a specific code lab designed for it to get more deep into the topic, because theming has always been a point of concern when it either comes to Android or Jetpack Compose. And Jetpack Compose has solved the problem of Android development by applying the material theming system, which allows you to customize theme on your own. As you can see in this example, in the given code snippet, this is my theme, and in which we have defined the colors and the typography and shapes. This means this particular theme would implement the components that has been derived in it. So the colors which has been put inside the material theme would be implemented in the whole background page, and the typography would be particularly used for that material theme. If you want to design another material theme, you are good to go to make your own. Now, Compose also offers a simple but powerful layout system. It's based on row and columns, which are roughly equivalent to horizontal and vertical linear layouts. If any one of you have worked with XML, you must be familiar with vertical and linear layouts. I know things have been a bit complicated that side, but in Compose, I promise you things are quite easy. As you can see, you simply have to write row and column or box, whatever you want to implement. And unlike the view system, however, the Compose layout model prevents multiple measure passes, making nested loops really easy. Now, constraint layout. with a compose specific DSL allows you to express more complex layout. As you can see in the given code snippet, we have just declared a constraint layout inside which the modifier has been applied with a modifier compose part, and inside that we have just put the avatar. Now, it's always been far simpler to create custom layouts, performing your own measurement and placement just to achieve the right layout, as it is easy to implement as a function. So I would recommend you all to go through the layouts code lab of Jetpack Compose to get more deep into this topic, because the layout components plays a very major role when it comes to UI theming in Compose. You can see the layout which has been defined in this particular code snippet. It has been simply placed using layout, inside which you place the height and width of that particular layout and the placeable objects. Now, one of the most exciting improvements is the new animation system. We as Android developers or UI designers have always been attracted towards animation system. But till now, animation has been really a very complicated task when it comes to at least exist Java. So Compose brings you a lot of easiness when it comes to animation. It's much simpler to use, offering really powerful and simple ways to bring motion in your UIs. They are also even working on motion layout to compose. Guys, once motion layout is out there, the animation would be really easy and awesome. So I would also recommend you all to go through the animation code lab of Jetpack Compose, which would be available in the chat box or in the description section. So testing and accessibility are first class citizen in Compose. Any Android developer who builds an app, testing has always been a point of concern, running on test cases or different things when it comes to navigation or semantic systems. They are both built on a particular system, which creates a parallel tree to the UI. The user interface that describes it provides more information to accessibility services, or even helping to match out new UI elements to assert against them, as you can see in the given example. Now, Compose also offers a declarative testing artifact that has been built to maximize the testability and offer easy APIs, which would allow you to test the rule, which would also expose the clock. As you can see in the given example, what we did, we simply used the @test and @test API to test the working of a particular animation. Guys, @test and @preview has been really a point of concern when it came in the initial time. But now, as Compose has moved to 1.0, the production level system has been made ready for @test and API. Now, when it comes to the full control access and when it comes to the testing animation code, I would also recommend you all to go through the Jetpack Compose testing code lab to improve your skills when it comes to testing on Jetpack Compose. So, as I have been talking about, Dhruv has been talking about Kotlin is entirely written in the Compose entirely written in Kotlin language. If you don't know about Kotlin, Kotlin has been said as the official language of Android development by Google and JetBrains, and it takes advantage of the great language features to build powerful intuitive APIs, and that is the reason Jetpack Compose chose Kotlin as its main language. Now, coroutines. Any of you who is familiar with a bit of Kotlin must be knowing about coroutines. Coroutines, for example, enables us to write much simpler async APIs, such as describing features, animation, or scrolling. You can see in the given example, what we did, we defined a coroutine scope inside which we declared the await pointer event scope. So this makes it easier to write code that combines async event like a gesture when hands are off an animation. Suppose you are working on an animation and you want that whenever I tap on that animation, that particular feature turns on, that animation turns on, and whenever my gesture is off that animation part, the animation turns off. Hence, async feature and the coroutines APIs would help you get into this really easily. Jetpack Compose and coroutines are connected to each other using the APIs system. So Kotlin also brings a powerful ecosystem of tooling. For example, making it trivial to extract UI components into new functions, promoting reuse. So you can imagine like this: whenever you create a function and you want to use that function particularly again in a coroutine scope or any other layout, you can simply extract it, and it would be really easy for the compose features to make a reuse of that particular function. To really understand these features, we will come up with an example. This is Owl. This is one of the official samples made by Google developers, which is available on GitHub. So you can go and check out the code, we would be discussing the code of the OWL application throughout this event now. So we would start building by an individual chip. We will write a new composable function that it accepts a topic model as a parameter. As you can see, what we did at the rate composable, write the function and inside which the topic has been mentioned, and we are good to go. After this, we would like to contain a row. We would like to build a component with a row containing an image and a text. This will show the data in a topic object. So if you are from XML background, you know things have take a bit of code there. But here you simply need to write row in and the bracket system obviously, and inside that just mention the image and the text. And guys, you're really good to go because you have already mentioned the topic and composable fun topic. Now, for the background, you can surround the row with a card composable. So, for a card composable, you don't need to write a bunch of code in like XML. Simply declare a card, and inside it fit the row. And we also want some spacing around the text. So, for that, we would decorate any composable using its modifier parameter. As you can see here, modifier is equals to modifier dot padding, and inside which how much padding you want. So suppose I want 16 dp, I would simply write 16 dot dp. Dp has been used as object here. Now you must be thinking, suppose we want to add a upper padding or lower padding. Simply press enter and write dot upper padding, and you are good to go. No need of bunch of code, just a simple line. So we want selected topics to come to have a check icon shown on the top of an image. We can achieve this by assigning a Boolean parameter. What we would do, we would simply declare a Boolean parameter inside which we would be checking out all out in a wrap in the image. We would wrap the image in a box which allows you to lag the items on top of each other and conditionally add the icons based on the selected parameters. So you can think like this: I touch the box, the icon would be there. I remove my finger, icon won't be there. Our design also calls for selected items to have rounded corners. And if you know about rounded corners, material U shifted from material design because of the rounded corners. Rounded corners has been a point of concern when it comes to Jetpack Compose in the initial stage. But now we can achieve this by conditionally setting a corner radius based on the selected parameters and passing that to card shape. You can see we have just declared val radius. We have declared how much radius we want, and after that we would set the animation. You can imagine like this: if we have selected that particular card, the radius would be 20 dp, or it would be just 0 dp. This is just basic data structures that have been applied here. Now to animate this, we can simply wrap this condition with a animate as state function. This will automatically animate the corner size change. As you can see in the working GIF at the right side, we have just wrapped the whole feature inside a animate state as DP. Now what is happening? Animation would happen if if the particular card has been selected, it would be 20 dp, else it would be 0 dp. Now the change in that 20 and 0 dp would be acting as the part of animation state. No, now so far we have created a single topic object, but on this screen we want to display a list of topics the user can choose. Let's create a new composable for this, which takes a list of objects as a part. So Compose also offers a lazy column composable, which helps lays element out vertically like a regular column, but it also allows you to pass out enough elements to fill the viewport, like a recycler view. If any one of you is familiar with basic XML or Kotlin, you would be knowing about the scrolling problem that has been there for recycler view and XML. So we can pass a list of objects to an item block. And if you remember in XML, we have to write a bunch of code for scrolling up in the list. But in Compose, simply declare lazy column and declare what items you want inside it, and you're good to go. So this is how the there would be rendering with each of the item, with each of the individual item. As you can see at the right side, the application has been scrolled down and scrolled up, and the rendering is happened with each of the item. What we did is simply declared a lazy column inside which we declared the modifier, and inside which we declared all the topics that have been there, all the items that have been there. Now coming to the next part, I guess that's it. No adapter or item layouts file, you are good to go. You have managed all the things. Item adapter is there to manage all of your stuff. You don't need to care about that. Now, however, our design calls for a horizontal staggered sequences of topics. This is also even easy to achieve in Compose by building a custom layout. Suppose building something like the grid show is only a couple line of code. In XML, you used to write a bunch of lines of code for just a simple grid. But here you can see we simply what we did. We did a measurable dot constants and we defined what we want inside it. Inside the layout, we defined a width and height and we declared it and we got a UI. And first, one last thing I'd like to show you in theming, Owl getting its yellow background from its theme. So you can see I've been focusing on theme from the beginning. You can see the theme that has been applied here is background, the yellow theme scaffold, and inside which the background color is being given. Now suppose you don't want yellow theme, but you want to keep this particular theme in your box. Simply keep it there and create another theme. Let that theme be black theme, and inside black theme declare whatever color you want. Let that be black theme. Inside that background color is equals to material theme dot colors dot black, and just implement that particular theme into your application and you're good to go. Now the complete implementation of Owl as well as the other 7 other samples are available in the official Compose samples repo. I would recommend you all to go through that and you would learn a lot of things from the official samples of Jetpack Compose by Google developers. Now hopefully that illustrates how Jetpack Compose makes it easier and faster to build UI. And that's just the scratching the surface. Jetpack Compose is built to coexist with the existing view system. Now suppose a lot of you must be thinking that Vishesh, I am from a background where I have been using Kotlin and XML. How can I shift myself directly to Jetpack Compose? So don't worry, it's really easy. Jetpack Compose can coexist with your XML layouts that have been working out. You can slowly implement parts of Jetpack Compose into a UI system. Now, Compose can adapt as gradually as you need, from replacing a small element of your screen to building a large piece of UI or an entire screen. As I told you, you don't need to worry at all. Just Compose helps you take down steps you need really slowly. Now, you can embed Compose within views as well as the hosting views within Compose. This can be especially useful for displaying content not built with Compose. So, such as ads or map views. This can help you gradually migrate to Compose, adapting it at your own pace. So most of you must be thinking that if Jetpack Compose is so new to the market, why would anyone other use that? So if you check the description section or in the chat box, there would be links provided to you of Jetpack Compose website. If you go on that website, you would realize big companies like Reddit, Twitter, and the task manager apps which have been using Kotlin and XML as their main APIs and for language have shifted to Jetpack Compose in recent days. Even Twitter tweeted it loves Jetpack Compose on its official Twitter handle. So the craze about Jetpack Compose is just overhyping. So one thing I would recommend you all that you should go through that migrate to Jetpack Compose code lab, because most of you have started Android development journey with either XML in Kotlin or with either XML in Java. But I would recommend you all to learn Jetpack Compose and implement that in your projects. The UI system made in Jetpack Compose has a very stable build and it's really beautiful. So in addition to this entropy, you can see we provide integration with other libraries so Compose can work with your existing application architecture. You don't need to start anything from scratch. So things that are integrated are navigation, view model, live data, paging, and Hilt. If you don't know about Hilt, Hilt is a very important thing that you should learn in Android development. So I would recommend you all to learn Dragger Hilt. Now, we also provide wrappers for common image, loading libraries, and adapters for converting material or app component XML themes into Compose. The following mentioned components are available for that, which includes navigation, view model, live data, paging, hilt, image loading, and theme adapters. So hopefully I have today showed you how Jetpack Compose makes it easier and faster to create great user interfaces. Now Jetpack Compose is the future of Android UI and will be stable soon. To get its time start learning. When Google I/O came, it was around Jetpack Compose 0.9, but now Jetpack Compose is 1.0, which means it's production ready as told by Through. So you can start your journey with Jetpack Compose, and as days passed, Jetpack Compose would slowly become more stable, and it's already being used by big companies like Twitter and Reddit. So you can take them as an inspiration for learning Jetpack Compose. And following are the resources which I would recommend you all to go through. The first resource is the pathway through which you can learn Jetpack Compose officially by Google and Android developers. The second is the Compose samples. As I've already told you, these samples are the official applications that are made by Google developers, and it's available on GitHub. Now, the third one is Compose documentations. It's my favorite because whenever I'm stuck on anything, or whenever I took part in any challenge, like you can see in the back, the Android Developer Challenge, I use these documentations. They help a lot. When it comes to the fourth point, the Slack. If you want to share anything on Compose, or if you have any doubt regarding Compose, you can go to their Slack channels and discuss with officially Google developers and Android developers that what you want in Jetpack Compose and how it can be implemented. Now, the last thing is the feedback forms. Suppose you are working with Compose and you feel like something is wrong here, and something should be improved when it comes to production build. You are free to go to the feedback forms and give the feedback to the Google developers and provide them with the features you want to get implemented in Jetpack Compose. So this was it for from my side. I hope you have got an idea today that how powerful Jetpack Compose is, and why it is the future of Android development, and why it is the future of Android 12. So this was it for from my side and GDSC VIT Bhopal. If you guys have got any question, you can ask that in the chat box and we will answer you.
Yeah, just to add to that, like thanks Vishesh for explaining the UI toolkit part. Somebody asked that if you can teach how to add Jetpack Compose to our Android Studio. So basically, we have
Yeah.
mentioned the link in the
So
chat. You can
Jetpack
follow
Compose
it.
is basically available if you want to add that into your uh, existing Android Studio. First of all, you would need at least Android Studio Architect Fox. What you need to do for that, simply go to Android developer website and download Android Studio, the latest version, which is Architect Fox. And once you install Architect Fox, it comes pre-installed with Jetpack Compose. Or if you have a previous version of Android Studio, simply update it and you're good to go with Jetpack Compose.
Yeah, so as Vishesh explained, you can follow that. And one someone asked that can we connect with you to discuss doubts on Android? So yeah, you can. Right now is the perfect time. You can ask questions in the chat box, or what you can do is you can come to our GDSC's Discord server. The link is in the description, and there you can ask us doubts, particularly in the Android channel. We'll help you out there.
Yeah. So I guess no one has got any more doubts. So
Yeah.
we can end the session, I guess, now. If any one of you face any kind of doubt, or you want to need any particular tips in Android development, you can ask me or through directly on Discord on the Android channel of GDSC VIT Bhopal. We would be really happy to help you out. And in future also, we would be coming up
Yes,
with a
definitely.
lot of events.
Yeah, this was the first technical event of this year, basically from GDSC VIT Bhopal, and it was of Android domain. So yes,
Hmm. So yeah, I guess everyone is cleared with the doubts, and all the links that we have provided to this.
someone just asked a question.
Yeah, if someone
Like
does
someone
not
just asked if someone does not know any
any
programming
programming
language,
language.
then what is the first
So
step to
if you
step
don't
in
know about
this?
any programming language, you
So
can
like
start with
basically
yeah.
is
True. So I hope Dhruv has told you how you can start with it. So this was it from our side. We would end the session now, as Sid has said. So thank you very much, guys. Have a nice day. Good night.
good night.